Okay, so today I am going to discuss angular momentum. I want to introduce angular momentum. Angular momentum. So what is the meaning of angular momentum? If you are having a particle, this is a particle of mass m, and it is moving like this in this direction. Okay, so it's with a velocity v. So what will be its linear momentum? Its linear momentum will be p equal to mv. Okay, its linear momentum will be p equal to mv. Now what will be the angular momentum of this about O? This is the point O, origin I say. Suppose this is origin here. Okay. So I want to find out the angular momentum of this particle about this point O. So position vector, first you have to write the position vector. Position vector will be r vector. This will be r vector. And angular momentum that is represented by L of this particle about this point O will be r cross p. R is the position vector of the particle and p is its linear momentum. P is its linear momentum. So angular momentum of a particle about some point O will be equal to the position vector of the particle with respect to that point. Okay, and take its cross product with the linear momentum of the particle. So L will be equal to R cross P. And what will the direction of this? What you have to do? So you extend this R vector. R vector will be like this. So this will have a rotational effect. Angular momentum comes during the rotational effect. This will be from R to V. So this will also be an axial vector. What will be the direction of this? This will be the direction here. ठीक है ना, here it will be like this will be the direction. So you have to curl your finger in the direction of this rotation, and direction of thumb will be the direction of the angular momentum. So this will be, suppose here I can show you, suppose this is a plane here I can show you in a much better way where you can observe. So try to understand, this is origin, and suppose here we are having a particle mass m. It is having some velocity v like this. Okay, so position vector of this will be r here. So mass is m. Okay, so linear momentum will be p vector. So what will the direction? Direction of L will be here. Try to understand, that will be perpendicular to this plane. Okay, and that will be perpendicular to this plane like this. So L vector will be in this direction. This will the direction of L vector. Okay, you have to rotate like this. This will be the direction. You have to rotate your fingers like this, and that will be perpendicular to this plane in this direction. So it will be like this. So basically here you can observe this L vector very similar to the direction of the torque vector. It is always, this L vector is along the axis of rotation. So in which direction this L vector will be? It will be parallel to the axis of rotation. What is this? This is axis of rotation. So L vector is parallel to axis of rotation. That's why this L vector, it is called as axial vector. Axial vector. In the last class when I was discussing torque was also parallel to the axis of rotation. Torque was parallel to the axis of rotation. So that's why they are called as axial vectors. These axial vectors, they actually come into the picture when rotational motion is involved. So you have to remember this formula, L equal to R cross P. For direction, it is very clear. It will try to rotate from the direction of R towards the direction of P. Rotation will take place. Rotation of your fingers will take place from the R vector, direction of R vector towards the direction of P vector. And then direction of thumb, it will indicate in the direction of L vector, angular momentum vector. This will be. Now, if you look at circular motion, ठीक है, in case of circular motion, then some particle is moving on the circumference of the circle like this, and here this is the particle whose mass is m, ठीक है, and its velocity, this will be in the tangent direction. So velocity or momentum, that will be like this, ठीक है. In the same direction you are having momentum p, and this will be r vector. This is o, this is r vector, ठीक है. So now, ठीक है, now what will be the direction? This is r. So basically rotation is taking place in this direction. So ठीक है, this you have to rotate your fingers from the direction of r in this way. So what will the direction of L? Direction of the L will be like this. This will be the direction of L. So particle is moving like this. So if particle is undergoing anti-clockwise direction, then this L vector will be here in the upward direction. If this particle is rotating clockwise, suppose this is V. In this case, if you look at L will be in the downward direction. If this particle is undergoing circular motion in the clockwise direction, then this will be the direction of the L. For clockwise motion of the particle, it is in the downward direction. For anti-clockwise direction, it is in the upward direction. So these are the directions. And now, what is the angle between this V vector or P vector and R vector? That is 90 degree. So in this case, for the circular motion, L vector, magnitude of L vector, it will be mvr, or I should write here, this will be r p, and this will be sine 90. ठीक है. This is r cross p. ठीक है. This is the direction of p vector. This is the direction of r vector. Angle between them is 90 degree. So magnitude of L will be rp sine 90. ठीक है. Sine 90 is 1 and p is equal to vr. So this will be, ठीक है, p will be equal to mv, and this r is here, and this will be the angular momentum. So here this will be mvr. So momentum is how much? mv multiplied by r, so mvr. This will be the angular momentum in case of circular motion, and its magnitude remains same. ठीक है. If it is uniform circular motion, v is not changing, then automatically L will remain constant. L will remain constant throughout the uniform circular motion. So this is mvr. ठीक है. Next thing, if you look, if I write this V from the circular motion, you know that V equal to R omega. So I can write this as mr square, and this will be omega. Now you are having a look here in this diagram, here or here, a particle of mass m is rotating at a distance r from the axis of rotation in the circular form. On the path of circular, on this circular path, this particle of mass m is rotating at a distance r. This distance is r. So what will be its moment of inertia? Moment of inertia of this particle when it is rotating around this axis of rotation at a distance r, it will be mr square. So this will be the moment of inertia, mr square. It is representing the moment of inertia, and this will be omega. So L can also be written as I omega. L can also be written as I omega. So L is equal to I omega also. Okay, so in case of circular motion, you can also use this one, L equal to I omega. So this is another formula for angular momentum. ठीक है? Now one more thing, if this axis of rotation is the principal axis, ठीक है? I have discussed this aspect when I was discussing moment of inertia tensor. You know that if axis of rotation, if axis of rotation, axis of rotation is the principal axis, is the principal axis, is the principal axis, then this L vector, then L vector, it will be parallel to omega vector. ठीक है? Omega vector. But if axis of rotation is not a principal axis, in that case you have to use here moment of inertia tensor. However, in case when axis of rotation is not, axis of rotation is not principal axis, is not a principal axis, principal axis, ठीक है? Then this L vector, it's not necessarily that it will be parallel to omega. In that case, this will be tensor here and that will be omega. Okay, you can write like this. So this will be in this way. So this will be L vector. So in that case, L and omega, they will not be parallel to each other. They are not necessarily parallel. But in case when they will become parallel only if axis of rotation becomes the principal axis. So principal axis is actually the axis of rotation. In that case, you have to remember this aspect. One last important aspect about angular momentum is, please note it down, then I will go to the next slide. Now, next. Now, suppose you are having a system of particles. This is XYZ system, axis, XYZ axis system. I'm not drawing Z axis, but here. And many particles are there like this. The system is made up of many particles. And here you are having center of mass. This is center of mass. So I will write this as RC. I'm writing it as RC, position vector of the center of mass. What will be the position vector of this particle? I'm choosing one particle here. Suppose this is of mass M1. And this will be the position vector of this particle with respect to center of mass. I will call it R1 prime. So what is R1 prime? R1 prime is the position vector of this particle M1 with respect to center of mass. With respect to origin, what is the position vector with respect to origin? Position vector is R1. R1. So what will be RC here? Sorry, what will be R1 here? R1 from the vector addition, you know that this R1, it will be equal to RC plus R1 prime. So it will be RC plus R1 prime. R1 prime. I just want to show you, even I can introduce it directly, but I think at your level you should understand the meaning of this article. That will be very, very helpful. So here you are dealing with a system. Here you are dealing with a system where system is having many particles. And for these particles, this is center of mass. So what I have written the position vector of a particle as the summation of the position vector of the center of mass plus position vector of that particle with respect to center of mass. So this will be now what will be the momentum? Okay, or you can say, what should I say here? This is R1. So what will be the momentum of the first particle P1? P1. Okay. What will be the linear momentum of this particle? Okay. This will be, even you can write, this will be M. Try to understand how can I will tell you how can you find out. I can say this is mass into VC. This will be VC plus P1 prime. P1 prime. This will be. How can I write this? I can write it very easily. Try to understand. I will remove it. So differentiate this equation with respect to time. So this will give you V1. V1. This will be VC plus V1 prime. Okay, now multiply this by M. Throughout multiply this by M. So M into V1. Okay, so this will become MV1. This is the momentum, linear momentum of the particle. This is P1. I'm writing it as P1. If you multiply here, that will be MVC. It will remain MVC. Okay? This is, you cannot write it. So this can be written as P1 because this is related to mass and velocity. They are related to individual particle. So I'm writing it as P1. But here, this is the mass of a single particle. And this VC is the VC is the velocity of the center of mass for the complete system. So it will remain as it is. It is going to remain MVC. I cannot write it as PC because in case of PC, it should be the total mass of the system. So that's why I cannot do this. Plus this will be M times V1 prime, or you can write it as M1. So what is this? This mass as well as this velocity, this is for individual particle. So I can write it as P1 prime. This will be. So in this way, I have written this equation. So please note it down if you want. Then I will then come back to this. So this is the momentum of this particle. Try to understand this is the momentum of this particle. And this is the position vector of this particle. So what will be the linear momentum of this particle with respect to the origin? So now write the angular momentum of the particle M1 of the particle M1 with respect to origin O. So this will be, you can say L1. This will be R1 cross. This will be P1. So this is the angular momentum of a single particle about this point O. And if I ask you what will be the angular momentum of this complete system about this point O, then you have to apply the sigma over here. Okay, you have to apply sigma over here. So angular momentum of the system, angular momentum of the system angular momentum of the system about O, about origin O. Now this will be sigma. In place of 1, you can write it as a I. in place of, because this is only a single, L1 is representing only one particle. Here I'm writing I, and this summation is for all the particles. And here it will be summation, this will be summation here, summation over I, and this will be Ri cross Pi. It will be like this. So I have taken the summation of the angular momentum of all the particles about the center of, about the about the origin here. So I calculated for one particle and take the summation so that I can find out the angular momentum of the complete system. So this will be the angular momentum here. This will be the L. This will be the angular momentum of the system. Here you can write summation. What is Ri? Ri is Rc plus Ri prime. This will be cross product. Take the cross product here. What will be this? This will be Mi Vc plus this is Pi prime. This will be. So now take the cross product of both sides. So first Rc cross this. So what it will be, you can write, this is Rc. ठीक है, Rc is the position vector of the center of mass. So sigma is not going to affect it. Then cross product, what it will be here, sigma is over this I. So this will be sigma over this Mi. And here Vc is not over this I. So this will be like this. So first term will be like this if you look. So sigma is going to act wherever this I is appearing in the picture, where many particles are appearing in the picture. So Rc, ठीक है, sigma is not going to act over it. Sigma is not going to act over it. It will act over here. This is the first term. Next, plus, this will be Rc, again, Rc, cross, this will be sigma over Pi. ठीक है? So Pi, it will be Mi, and this is Vi prime. It will be like this. ठीक है? So I have used this with this first, and this is second term. It is like this. So I have written like this. Next, take this one. So plus, this is Ri, sigma Ri. This will be Mi. ठीक है? Ri, sigma. So what can I do? Here I can write, this is Mi, and this is Ri prime. Ri prime. I'm writing it as like this, and this cross Vc. This is Vc. And last one is plus, this is Ri prime. ठीक है? Cross, this is Pi prime. Sigma will be here, and this will be Pi prime. ठीक है? This will be for the complete system. Try to understand one thing. This, what is this? This is MIVI. What is this? This is sigma Mi, and look at this. This is sigma MIRI prime. So how much they will be? Can you tell me what will be the value of this from the basic definition of the center of mass? From the basic definition of the center of mass, can you tell me what it will be? बोलो बेटा. बोलिए. बोलो बेटा, what is this? What is the definition of center of mass? Center of mass is that point about which mass moment of all the particles is zero. And what is this? MIRI prime. This is the mass moment of all the particles about center of mass. RI prime is the position vector of the particles with respect to center of mass. So what is this? This is the mass moment of all the particles about the center of mass. So this will be zero. Why it will be zero? Because mass moment of all the particles about center of mass is always zero, is always zero. This will be zero. So that's why this will be zero. This term is going to be zero. If you look at this term, okay, what can you do here? I can explain this term here. What is this term? If you look at this sigma MIVI, VI here. Okay. So how can you write? You can write this term as d by dt of sigma of, this is Vi prime, Mi Ri prime, MIRI, and this is zero. Try to understand, this is again the same thing. So this will be zero. So this term is going to be zero again. So this term, that will also be zero due to the same reason. So now you are left with these two terms. This will be the total mass. What will be this in the bracket? This will be the total mass. So here L vector is, this will be RC into, this will be total mass of the body, and this is VC. Okay. So what is this? This is the momentum of the system. Total momentum of the system. This is second plus, this is sigma Ri prime cross Pi prime. Can anyone recognize this? What is the meaning of this first term? RC cross MVC. So L is made up of two terms. This is RC, position vector of the center of mass, cross product with total mass focused on the center of mass into VC. What is this? So this is the total momentum of the system that is acting at center of mass. And you are taking the cross product of the position of that center of mass. So this is the linear momentum of the center of mass. This is the linear momentum of the center of mass with respect to origin. So this term is, this is not linear momentum, angular momentum, sorry. This is angular momentum of center of mass about origin. This is the first term. Plus second term is, if you look, sigma Ri prime, position vector of all the particles with respect to center of mass, cross momentum of each and every particle with respect to center of mass. It is. So what is this? This is the center of the, this is the angular momentum of the body about center of mass. So what is this? Plus, this is angular momentum of the body about its center of mass itself. ठीक है? So this will be, so total angular momentum of the system will be this. So this will be the total angular momentum. So here, more simplify I can make you. This is RC cross MVC. It appears directly what is the meaning of this. Plus, this is the angular momentum of the body about an axis passing through its center of mass. So this will be how much? This will be I omega. ठीक है? This will be I omega. So in this way, this will be the total angular momentum about a particular point. Here, I'm considering that point as the origin. Here, we are considering that point as the origin. Is it clear up to this point, beta?
Yes, sir.
This is very important to solve the question. Many of the students, they don't know what is the meaning, how to calculate this angular momentum about a fixed point. Now, I'm giving you an example. Just one second. As an example here, suppose we are having a sphere. ठीक है? It is like this, and it is moving with this velocity we see here. This is, and this is origin. So this type of diagram is given, and radius of this sphere is r, or even you can write this is v naught. This is origin here. Now please write the question: a sphere of mass m and radius r. A sphere. So a sphere of mass m and radius r, solid sphere I am talking about. A sphere of mass m and radius r having velocity of center of mass v naught. Having velocity of center of mass v naught is moving, is rolling, you can write is rolling without slipping. Is rolling without slipping. Slip नहीं कर रहा है. Is rolling without slipping. Is rolling without slipping. Full stop. A part A. Find the angular momentum. Find its angular momentum about center of mass C. Here I am saying this is center of mass C. Find its angular momentum about its center of mass C. B part. Find the angular momentum about the point of contact P. Find the angular momentum about the point of contact P. And C part. Find the angular momentum about point O. This is point O. So what you have to do, you have to find out the angular momentum of this sphere which is undergoing rolling without slipping condition. Okay, it is rolling but it is not slipping. It is moving, its center of mass is moving forward with a velocity v naught, and you have to find out its angular momentum about 3 points, about its own center of mass, about P, and about O. सो वन बाई वन, ठीक है, वन बाई वन। फर्स्ट, एंगुलर मोमेंटम, एंगुलर मोमेंटम about center of mass C, center of mass C. So what it will be? Simply I omega. It will be I omega. So here is specific point with respect to which try to understand this is your formula. So what is this RC? What is this RC? RC is the position vector of the center of mass with respect to specific point. Here my specific point is C. They are saying me to calculate the angular momentum with respect to C. So where is my specific point? My specific point is center of mass itself. So position vector of center of mass with respect to C will be 0. So in this case, in the first case here, RC, ठीक है ना, that will become 0. ठीक है ना? So that RC, I'm not saying with respect to O, but try to understand what I want to say here, that position vector of C with respect to itself will be 0. So first term will be 0. So what will be the angular momentum? That will be simply I omega. This will be I omega. What will be I for the solid sphere? Moment of inertia of the solid sphere. That will be 2 by 5 mr square. That is 2 by 5 mr square. ठीक है? And next is this omega. Suppose it is rolling like this. I am saying this is rolling like this. ठीक है? So if you write L like this, omega like this, omega will be, ठीक है ना? If you look at omega, if they are providing me omega, then I can directly write omega. But here omega will be, yeah, you can say this is R omega. That will be V naught. ठीक है ना? So omega will be V naught upon R. So I will write V naught upon R. What will be the direction of angular momentum? You have in which direction this rolling motion is taking place. It is like this. You have to curl your finger like this. So it will be inward the board. It is inward the board. ठीक है? So if this is x-axis, this is y-axis. ठीक है? Then z-axis will be in the outward direction, x, y, z system, right-handed system. So inward the board will be minus z cap. So this will be the direction of the angular momentum. So 1r will cancel out and it will be 2 by 5 mr v naught minus z cap. This will be the angular momentum of this sphere with respect to the point C. This is the first case. Second, you want to find out angular momentum about point of contact P, about point of contact P. So this is point of contact. ठीक है? So what will be the position of center of mass? What will be the position vector of center of mass with respect to P? So look here. This will be with respect to P, position vector will be this one. To understand the direction of rotation, I'm drawing like this. So this is, ठीक है ना? Its magnitude is R. This is the position vector. Magnitude of this position vector will be R, and this will be the direction. And this will be the direction. Try to understand. ठीक है? So first, what will be L vector here? L vector. ठीक है? It is this direction, so you can draw here. ठीक है? This is first. So what is the first term? If you look, you remember that is VC cross MVC. This is RC, sorry. This is RC, first term is RC cross MVC. Okay, this is the first term. So position vector is this one. So I write it as R. Okay, R, and it will be in the y cap direction. This will be in y cap direction here. Okay, y cap direction. And this will be cross product. Cross product. This will be MV naught. And V naught is in x cap direction. It is in x cap direction. So this will be the first term of the angular momentum. Second will be I omega. So I omega will remain same. So this will remain same. Minus 2 by 5 mr V naught z cap. So this will be y cross x. X cross y z cap. Y cross x minus z cap. So this will be minus mr V naught z cap. This will be minus 2 by 5 mr V naught z cap. So this will be total 5 and 2 7. 7 by 5 mr V naught z cap. This will be. Okay, this will be beta. So it will be in this direction. So try to understand. So it will be inward. It will be inward beta. So it is like this. So if you look at this, you want to find out this direction like this. This is R and this cross V. So in this way, rotation is taking place. So basically it is supporting its own angular momentum is in this direction, and this first one, this is also helping him. So this will be minus 7 by 5 mr V naught z cap. So this type of rotation is taking place here. Now third, you have to find out the angular momentum of this sphere with respect to this point O. So you are now changing the point of reference. Here my point of reference is here. So what will be my RC now? Try to understand. My RC will be this. Try to understand. This will be my RC. This will be my new RC. This will be RC here. Okay? And suppose this angle is theta. And this will be MV naught. This will be MV naught. So what will be the angular momentum here? I am writing. Third, C, angular momentum. Or I should write on the next page. Angular momentum. Third, angular momentum about point O. About point O. Okay? So this will be simply L. This will be RC vector first. That will be RC vector. Okay? Cross product MV naught. What is the angle between this new RC and MV naught? Try to understand this angle. So if you expand this here, if you are expanding this, so this angle theta, this angle or this angle, they are same. So this will be the first term here. So this first term, first I'm writing this, I'm writing it as RC, and this will be MV naught, V naught, and this will be sine theta. And direction will be minus z cap. Still it is minus z cap. Second term will be I omega. So this will remain minus 2 by 5 mr v naught z cap. Now, if you look at this RC sine theta in this diagram, this is RC, this is sine theta. So RC in this right angle triangle, this RC sine theta will be equal to this perpendicular. This is hypotenuse, this is RC, this is sine theta. So RC sine theta will be perpendicular. And perpendicular height of this perpendicular is capital R. So RC sine theta can be replaced from here. You can look RC sine theta. This will be equal to R. So I can write it here. This is RC sine theta. That is R. So I can write it as M R V naught minus sign here. This will be Z cap minus 2 by 5 M R V naught Z cap. So this will be minus 7 by 5 mr v naught z cap. So this will be the angular momentum. Okay, so here I explained you how to find out the angular momentum of a system about different points. One thing is you have to find out the angular momentum of the center of mass about that particular point. Second, you have to find out the angular momentum of the body about the center of mass itself. Make the sum of these two, you will find out the total angular moment. That will give you the total angular momentum. So this is very famous question. In all the standard books, you will find out this question in one way or another. This is a very good question. Is it clear what I'm saying here?
Yes, sir.
Yes, sir. Good. Now, next example. Second example, please note it down. Now, you are having a wooden log like this. This is example 2. You are having a wooden log of mass capital M. Okay, it is here. It can rotate about this point. Okay, na? So this is hinging point. It can rotate. Pivoted point. This is pivoted point P. It can rotate about this. Its mass is M, length is L. So I can say length is L and mass of this is M. I'm saying mass M. Now what happens? A bullet. Okay, a bullet. It is moving here and it will hit this one, hit this log and it fixes into it और वो इसके साथ अटैच हो जाता है. ठीक है, a bullet of mass m and take it some velocity v, suppose, or v naught, you can say this is v naught. A bullet of mass small m and velocity v, it is going to hit this log here. So it is going to hit this log here and it will fix with it. ठीक है ना, it will attach with it. तो ये इसी के साथ अटैच हो जाता है, स्टिक हो जाता है. नाउ फाइंड द एंगुलर वेलोसिटी ऑफ द सिस्टम just after this collision. Just after this collision, immediately after the collision, you have to find out the angular velocity of this system. So due to this system will rotate like this around it. So please, can you tell me how to find out this omega? ठीक है, this angular velocity, or you can write the question if you want. Please write a wooden log of mass capital M. Yes, Peter, please. Is it okay? If you want to write question, I can dictate. Please write a wooden log of mass capital M. A wooden log of mass capital M and length L is hinged at point P. At point P. Full stop. A bullet of mass small m. A bullet of mass small m strikes with velocity v naught. Strikes with velocity v naught. and sticks to it, and sticks to it, and sticks to it, full stop. Find the angular velocity of the system. Find the angular velocity of the system immediately after the collision. Immediately after the collision. You have to find out. Can anyone tell me? So here, try to understand no external force is there, no external torque is there. So on this system, ठीक है, no external force is there which can create a torque. ठीक है, so first thing is this. So angular momentum of the system will remain conserved. In the last class, I told you if torque is external torque is there, and this will be dl by dt. And if there is no external torque, the meaning of this is this angular momentum of the system, it will remain constant. It will be constant. So angular momentum. So what will be the initial angular momentum? Li. Li. This will be equal to Lf. What is Li? Initially, it was at rest. Only this was moving. So it is going to have momentum. mv naught. mv naught is the momentum. Okay. So mv naught is the momentum. So what will be? Can you tell me what will be this? What will be this angular momentum of this bullet, moving bullet with respect to this point O? So this is line of action of its motion. And if you draw a perpendicular from here to here, this is length L. So this will be simply mv naught into L. ठीक है, m v naught into L. ठीक है, this will be, what will the direction of rotation, possible rotation? This is r vector here when it is going to hit here. Try to understand when it is hitting here, it is at this position. So this will be the direction of r vector at the time of collision. Second, what will be the direction of momentum? It will be in this direction. This will be P. This will be R. So in this direction, possible rotation will take place. So angular momentum will be corresponding to this type of rotation in the outward direction. It will be in the outward direction. So this is initial momentum. Okay. And here, okay, now what will happen after this? This bullet will fix here. It will stick here. After collision, this bullet is going to stick here with this. So now this complete system, it is going to rotate like this. ठीक है ना? It will try to rotate with omega about this axis. So what it will be? This will be I omega. I omega. So no translational motion is there. Just it is rotating. This rod is going to rotate like this. So this will be I omega. What will be the moment of inertia of this rod as well as this bullet? So first, can you tell me if you are having a rod like this of length L and mass M? You are having a rod of length L and mass M. You start rotating about this axis. ठीक है? This axis. What will be its moment of inertia? That will be, if you remember, 1 by 3 ml square or ml square by 3. Second, here, look here. If you are having a mass M attached here, a mass bullet, ठीक है, mass of bullet M is attached here. So for this rod, moment of inertia will be 1 by 3 ml square. And this mass is also rotating at a distance. So this mass, try to understand, this mass is going to undergo this type of rotation about this axis of rotation. It will be like this. So mass m at what distance from the axis of rotation, that is length L. So this will be plus m L square will be there. So this will be the total moment of inertia. So this will be m v naught L, and this will be equal to 1 by 3 ml square plus ml square, and that will be omega here. ठीक है, omega here. So what you want to find out? You want to find out omega. So this will be 3m. So you can write this as omega by 3 here. L square is here. And in bracket, this will be m plus 3 small m. On this side, this will be. So one of the L from this side, it will cancel out. So this will be 3 mv naught. What will be omega? This will be 3 m v naught divided by L m plus, this will be 3m. ठीक है, this will be 3 mv naught upon this, 3 mv naught upon L m plus 3m. This will be the angular velocity with which this road plus bullet, they will rotate. They will rotate. So just after the collision, just after this bullet sticks with it, ठीक है ना, this will be the angular momentum, omega. So this is another question that is quite good. Is it okay?
Yes, sir.
Next. Question number 3. Please write question number 3. Third example, please write. If the radius of the earth contracts, if the radius of the earth contracts to half of its present day value, if the radius of the earth, suppose this is the radius of the earth, if the radius of the earth contracts to half of its present day value, contracts to half of its present value, without change in its mass, without change in its mass, without change in its mass, comma, what will be the length of the day? What will be the length of the day? What will be the length of the day? So initially, you are having this type of earth. Our earth is like this, and it is rotating about its axis like this. Time period for one rotation is 24 hours. Second, radius of the earth is RE. Now what happens? Some internal phenomena, internal process takes place. ठीक है, and it shrinks. So some type of attractive force comes into the picture. No external force is there, and it contracts in such a way that its radius becomes half. So now what will the length of the day? So you want to find out T prime. What it will be T prime? If here nu RE prime, that is half of the original value. So here no external torque is acting on the system. You can observe whatever is happening here, that is some internal phenomena. ठीक है, no external thing is not mentioned here. No external force or torque that is acting on the system, it is not mentioned in the question. So angular momentum will remain same. Angular momentum is not going to change. Mass here is m, mass here is m. So angular momentum, apply the conservation of angular momentum. Conservation of angular momentum. Angular momentum. So this will be I1 omega 1 initially. This will be I2 omega 2. Here I am assuming our Earth as the sphere. So it will be, what will be its moment of inertia? That will be 2 by 5. Mass is m. This is re square. Okay? And this will be 2 pi by omega will be 2 pi by t1. I2 after shrinking, it will be 2 by 5. Mass will remain same. Radius becomes half. So this will be re by 2 square. And I want to find out t2. So this will be 2 pi by t2. T2. So look here, this 2 by 5, this 2, this by 5, this 2, this by 5, that is going to cancel out. This 2 pi will cancel out. So this 2 T2 will be here. So this T2 is here, T1 is here. RE square will cancel out and it will be, we will be left with 4. So T1 is 24 hours. This will be 4. So this will be 6 hours. Okay. So time period, daytime, it will be 6 hours. Okay. So it will be 6 hours here. Will be the day length. Length of the day will be 6 hours. So it is like this. Is it clear, beta, whatever I have discussed today?
Yes, sir.
So in the next class, first I am going to discuss more questions related to whatever torque I have discussed, angular momentum and rotational. I will also discuss rotational kinetic energy. That is very simple, take 5 to 10 minutes. And of all the three, rotational kinetic energy, torque, angular momentum, I will try to discuss the question and center of mass. First, I am going to discuss these questions and then I will go for rolling without slipping motion. So please save these slides. This is the first one. Second, third, fourth, fifth, sixth, seventh, eighth, nine, and 10.